One and one.
Okay,
Okay, we can start.
so let me start. Hello, everybody. Welcome to today's webinar. Good afternoon to you all. I'm Alok Bhaumik, and I'm the chairman, Professional Development and Technical Events Committee of IE Structi. First of all, I thank you all for participating in this webinar and also many other webinars on refresher courses that are being organized by IE Structi. Last week, many of you might have, participated in the excellent webinar that we had on Narendra Modi Stadium, Ahmedabad, which was pretty well attended and very well appreciated also. Today's webinar is on another very interesting topic, which is demolition of structures, issues and challenges. Usually, we discuss construction of structures and rehabilitation of structures, but rarely we have deliberations on demolition of structures. So this is one such very unique webinar where we will be discussing demolition of engineered demolitions of structures. Uh, we all know that there is, in the recent past, there has been an increased number of buildings and bridges which are being demolished due to several reasons. It may be due to the pressure of rapid urbanization, which demands the clearing of the waterway for larger development. It may be due to replacing of the old unsafe structure with a new one, or it may be due to the need to remove a non-conforming structure which is having faulty construction. Whatever be the cause, the process of demolition of any structure is pretty complex. It requires specialist engineering inputs from multidisciplinary fields. The process is fraught with many challenges and risks. Very high level of engineering skill is needed for the deconstruction process of any structure. Realizing the importance of deconstruction technology, our association thought that it is prudent to bring this issue in the forefront of discussion in the fraternity, and that is how this webinar was conceived. In this webinar, we have three very eminent speakers: Dr. Anil Joseph, Mr. Sanjay Kumar Jain, and Mr. Shashank Rajbhoj. They will be presenting the case study of three completely different set of challenging demolition projects in India. Uh, they will be covering demolition of multi-storied buildings, major bridges over mighty river Ganga, and a land-based ROB over an extremely busy railway track. Uh, so we are also very fortunate today to have with us an expert panelist, Dr. P.R. Swaroop of CIDC, who will share with us his experience and knowledge also on the subject after all the three speakers speak. The webinar will be moderated by an eminent personality in the profession, Mr. BCS Rao. Apart from holding many responsible positions in the profession, he is a governing council member of our association, and I have the privilege to introduce him. Mr. BSC Rao has over 48 years of experience in planning, design, construction, and project management of large infrastructure projects. He has vast experience and specialization in all aspects of metro rail projects, and he has worked on many international metro projects also, like Singapore Metro, Taipei Metro. He was executive director of the first PPP based metro rail project in India, the erstwhile Elevated Light Rail Transit System project. And he has been involved with Hyderabad Metro Rail project right from its inception in 2010. He is also a chartered engineer of the Engineering Council UK. He is a member of the Institution of Structural Engineers UK. He is a fellow and life member of several professional societies. He was instrumental in organizing many national and international conferences under the auspices of ACCE in the past. Before the floor is handed over to the moderator, it is a delight for me to invite our president, Mr. Manoj Mittal, to say a few words. Mr. Mittal is very well known in the fraternity and do not require any introduction. He is a practicing consulting civil and structural engineer, member of several professional bodies and many code committees of BIS. He is also affiliated with SPA New Delhi as a visiting faculty. Over to you, Mr. President.
Thank you, Alok. Once again, I welcome you all to this important webinar on demolition of structures. As Alok said, this is a very new kind of a thing for engineers. Generally, we believe in construction, but demolition or deconstruction is also equally important, and we need to know about it. So today we have very eminent speakers, moderator and panelist. I welcome you all. I also welcome all the participants in this event. I hope everybody will gain with this webinar. As you know, IS30, that is the Indian Association of Structural Engineers, is a national level apex body of structural engineers in India. And its governing council consists of leading practicing structural engineers from all over India. And I'm very happy that we have several committees, including this Professional Development and Technical Events Committee. And all the committees are very effective, very functional, and they are doing a lot of good work. We organize several technical events, webinars, seminars, and all those things. We also publish technical code commentaries and guidelines in the interest of the engineers. We also publish quarterly journal, technical journal, that is SED, Structural Engineering Digest. So all those things are very popular, and if you are not a member of ISTT, I encourage you to become the member of ISTT. You can go to the website, you can get the membership form and eligibility criteria, and it will be a very enriching experience for you to join ISTT. Now, another important thing I want to say that last year ISTT started a few awards in the field of structural engineering, and these are in various categories like Structure of the Year Award, Structural Engineer of the Award, Promising Structural Engineer. There are several categories. So this year 2021 awards will be announced very soon. I think you will be interested in looking for it. And whenever the announcement comes, please try to nominate yourself or suggest to your colleagues for that. Thank you. Now I request Engineer B.S.C. Rao, moderator of the event, to kindly start the event. Thank you.
Thank you, Mr. President. Thank you also, Alok, for that nice, very short introduction. And I would like to welcome everybody to this webinar. Good evening and to everyone. We are all very familiar with structural failures and collapses of buildings and bridges, which seem to be occurring in our country with unfailing and depressing regularity. But perhaps what is less familiar is that there is a very great need for deliberate demolition or deconstruction of structures for a variety of reasons, as Alok has already mentioned, which include very old and dilapidated structures, structures damaged by accidents, earthquakes, floods, and so on, or just to clear large areas for redevelopment and construction of new structures in a city. As Mr. Alok Bhaumik has already introduced the subject of the webinar, and he has given a brief introduction to what it's going to cover, I will skip that part of it and go straight to the speakers. As Mr. Bhaumik has already mentioned, we have three eminent and very experienced speakers who will be presenting case studies of three very challenging demolition projects in India. Incidentally, there is a very big market for demolition in India, and there are literally hundreds of companies that do engineered demolition. I thank all the speakers and the panelists for taking part in this seminar, and I would like to welcome them too. As time is a constraint, I would like, excuse me. Sorry. As time is a constraint, I would like the speakers to kindly limit their talk to 25 minutes at most. And to help you in this, I will give you a gentle reminder about 5 minutes before your closing time. I will also introduce each speaker just before he makes his presentation. All the three presentations will be followed by a panel discussion of about 20 minutes. The panelists will be the three speakers and will be joined by the very well-known Dr. P.R. Swaroop, who is the Director General of the Construction Industry Development Council, after which we will have a very short question and answer session. I request all participants to please post their questions in the Q&A box and not in the chat box. And in the interest of saving time, I further request all the speakers to answer as many of the questions in the Q&A box directly, so that will save time in the question and answer session. Now, to commence today's webinar, I would like to introduce first Dr. Anil Joseph, who is a director of Geostructurals Private Limited. Dr. Joseph got his graduate and postgraduate degrees in civil engineering from National Institute of Technology, Surat, and subsequently earned his PhD from NIT Calicut for his work on pre-compression of soft marine clays, and from Open International University for his work on pre-stressing and hollow shell technology in earthquake-resistant construction. He is director of Geostructurals Private Limited, a leading firm dealing with foundation and structural consultancy based in Cochin. In the last 28 years of his illustrious career, he has provided consultancy for more than 2,000 high-rise structures and infrastructure projects in India and overseas. He is also the managing director of Seacons Private Limited, a construction firm specialized in the execution of pile foundations, and also director of Engineers Diagnostic Center Private Limited, a firm specializing in geotechnical investigation and retrofitting works. With that short introduction, in fact, his biodata is much longer, but I've had to cut it down in the interest of time. I will now hand over the floor to Dr. Joseph to speak on demolition by implosion of high-rise structures. Over to you, Dr. Joseph.
Thank you.
Sir, you have got 25 minutes, and at 20 minutes, I'll give you a short reminder. I hope you don't mind.
Thank you very much. So we'll try to make it short. Thank you, BSC Rao sir, for the introduction, and thank you, President Manoj Mittal and Alok Bhomik for inviting me to do this presentation in the Indian Association of Structural Engineers, and I feel it's a privileged opportunity, and thank you, the organization. And like pointed out, we have to share our knowledge, and the controlled demolition is becoming an essentiality. So even we are constructing, we have to start planning for how to decommission the project also. It's also becoming very vital, and we need to have a specialist team coming on that. Let me start sharing my presentation. So we are presenting a case study, the demolition of apartments at Marriott Cochin, and as part of this presentation. And let me run through, as the time is a bit short. Demolition can be defined as dismantling, razing, destroying, or racking any building or structure or any part thereof by pre-planned and controlled manner. Whenever a structure is to be demolished, it must be seen that the method adopted, it takes minimum duration, produce less noise, cause no pollution beyond permissible limits, does not disturb the activity or living in the neighborhood, and is economically viable. The demolition method is selected after pre-demolition works such as surveying, removal of hazardous material, and stability analysis reports. Demolition method also varies with the type of structure, structural member, demolition range, rural or urban area, and frequency. The application of method for demolition depends upon actual site condition and availability of demolition equipment. So there are principally three types of structure demolition. One is the progressive demolition, second is mechanism of controlled demolition, and third is the top-down system. So in the progressive demolition, by wrecking or taking out any loads supporting structural member, part by part before the building completely falls, at the same time considering the structural stability, so the building will not collapse simultaneously. It is commonly adapted to high rate of catch area and commonly practiced using heavy machinery and equipment. The heavy machinery or equipment include large motorized vehicles such as bulldozers with rakes, backhoes, hydraulic excavators, and other similar machinery. Cranes equipped with wrecking ball, clamshell, or bucket are also considered heavy machinery. In the mechanism of controlled demolition, it's a technique to demolish, wrecking or taking out of the main structural member or element before the building completely fall, fully or partially demolished, equal to progressive demolition. It is commonly adapted to big catch area condition and usually practiced using explosion or implosion and wire rope pulling methods or any other suitable methods. Deconstruction or top-down method is the technique that proceeds from the roof to ground in a general trend. There are particular sequence of demolition which may vary depending on site condition and structural elements to be demolished. It is the process of dismantling a building in order to salvage the structural members for material reuse and recovery, and commonly practices by machinery and hand demolition methods. Top-down method is applicable for most sites, particularly for those situated in busy urban areas. And coming to our topic of discussion today, demolition of building by implosion. Implosion or explosion deconstruction is an effective and efficient method of deconstruction and can reduce both cost and time to bring dangerous multi-story structures to ground in comparison to conventional demolition method. Implosion is the strategic placing of explosive material and timing of its detonation so that a structure collapses on itself in a matter of seconds, minimizing the physical damages to its immediate surroundings. The technique weakens or removes critical support so that building can no longer withstand the force of gravity and it falls under its own weight. So before we go for blast, there are many considerations which we have to look into. The design may include pre-weakening of the structure, the strategy in placement of the explosive, and time delay so that the building will collapse in a safe manner. The pre-weakening of the structure may include cutting out a portion of the shear walls and other structural elements, removing the non-load bearing walls. A test blast may be conducted to verify the strength of the structural member and to fine-tune the explosive design. To minimize the dispersion of building debris into adjoining land after implosion, a trench or bunt wall shall be installed outside the building to contain the debris unless a basement exists. And after filling the explosive, it will be covered with geotextile wrapping and iron mesh wrapping in order to prevent the flying debris going out and creating havoc. So this is a good design will cause the structure to fall towards the center of the building. So these are the sequence of the explosion needed. And this is the test blast before and after to understand what is the energy or what is the explosive and degree of explosive needed for going for the explosion. And this is the wrapping of the hole in order to prevent the flying debris from flying away. And finally, we will go for ballasting with the time sequencing so that the building falls on in a gradual and planned manner, and the collapse is controlled in such a way that way it comes down without affecting the surrounding buildings. So this is the picture presentation of what I talked now, the conventional top-down method, the wrecking ball method, the hydraulic crusher. Now we have hydraulic crusher with loam boom going up to even 45 meters. And finally, we will come to the implosion method. So these are the comparison between the different system. I am not spending much time on that, how to make the judgment on how to go about that, whether it should be top-down manual method, top-down machine with hydraulic crusher with loam boom, wrecking ball, or should we go for the implosion technology, the principle, general condition, and what are the benefits. Now looking into this, what we do in implosion, use of explosives, protection from noise, debris, and vibration. You need qualified blast heads, good engineering skill between structural engineers, mining engineers, electrical engineers, electronic engineers, and the fire and safety department and the neighborhood. The administration also has to be brought in. Notification and evacuation of the neighborhood, check and cautionary handle of mishearing, excellent demolition strength, could shorten the demolition period and reduce labor risk. Risk assessment required to be continued. So now moving on to the case study for the apartment at Marad. Marad is just 7 kilometers from Cochin and it was formed in 53, was upgraded to a municipality in 2011. On September 2006, the Panchayat, without obtaining the mandatory permission from the Kerala Coastal Zone Management Authority issued building permits to the builders. So builders started constructing the building. The piling works was carried out. The building was coming up, and suddenly the Coastal Zone Management Authorities realized that this is not legal. This was not there. Got the permission. They went and put a stay for the building. But owners approached the court, and court gave them permission to continue. And the building was, there was so much of legal tussle going on from 2007 till this 2019, when it was finally decided to bring it down. I am not going to the details of the case. We'll share with the audience in another occasion. People began to occupy the flats as early as 2010, and 2012 all the buildings were completed, and about 367 families were staying in that apartment for 7 years. And this is the court order of Supreme Court order on May 8, 2019, when Justice Arun Mishra and Naveen Sinha said permission granted by the Panchayat was illegal and void. No such development activity could have taken place. In view of the findings of the inquiry committee, let all the structures be removed forthwith within a period of 1 month from May 8, 2009, and complaints be reported to court. In September the 6th, the Supreme Court ordered another direction that the state government to demolish the apartment before 12th February 2020 and remove all the debris and clear the site. So eviction notice was served to the residents subsequent to this. Meerut municipality issued notices to the residents of this apartment to move out of their home. Residents say that they will resist the eviction. And you can see that Supreme Court verdict came as a rude shock to the resident. Several political parties and organizations rallied behind the residents, and there was a lot of protest. Supreme Court refused to entertain another batch of review petition. In fact, there were 17 review petitions filed after I was appointed as the structural engineer to supporting the government to bring down the buildings. And all the 17 appeals were refused by the Supreme Court, and state government proceed to execute the work order. So this is the people who are staying in the home, in their houses. Demolition is cruelty to the mankind, and they are protesting against the demolition activity of the government. And again, the activity, you can see that this was a long-term process. And to inform the audience, I was the structural engineer who have designed all these buildings other than one. The small building, all the 4 other towers was designed by me as a structural engineer in the year 2006. And the buildings were constructed under my guidance. Unfortunately, this role was so vague, nobody had a clear-cut idea. And finally, since it was surrounded by so many buildings and government put so much of pressure on me, I have to take up the responsibility for getting the building down also. So had the dual role of the Brahma, the creator, and Shiva, the destructor in this particular project. And it is quite an emotional thing. And in October 2, I was not still part of the government team, and I shared my apprehension in the local news channels about the demolition of Meerut flat and raised concern of the safety of the neighborhood. And representing Association of Structural and Geotechnical Consultants, we had a couple of round of meeting with collector and other office bearers, including the principal secretary. And government order was released appointing myself as a member of the technical committee for demolition, representing Association of Structural and Geotechnical Consultants. If the entire structure is demolished at one go, without proper study and planning, it will result in large ecological disaster, seriously affecting the environment and inhabitants of nearby places. The method of demolition should be carefully decided in consultation with experts. We invited expression of interest for demolition of the 4 apartments because we only had demolition by implosion as the practical solution due to the time frame, and 16 agencies came forward. So a lot of discussion and deliberation happened, a lot of reviews were conducted, and finally we decided to zero in on Edifice Engineering Mumbai and Vijay Steel from Chennai to do that. And Edifice has given the work to Jet Demolition from South Africa to do the job. So the step for the controlled demolition, if we put in a simple manner, it will be step 1, survey surrounding area to determine if structure should fall on one side or collapse on itself. Study building plan to see where explosive can be placed. Remove toxic substance like asbestos, flammable material, glass and furniture. Remove non-load bearing walls. Drill hole in columns and place explosive. Cover column with geotextile in order to prevent flying debris, and go for the detonation. So now let us get into the challenges in demolition of apartment. If on the theory it was very good, we were studying so many failures has happened across the world where they have gone for demolition. People have died during the explosion. Even people who were standing at 1 kilometer away had died. There was a case of Canberra Hospital where a girl of 12 years was killed at 450 meters away. So we were very apprehensive and we looked into the challenges in the demolition of apartments of these projects. And so you can see the towers here. So this is the Alpha Serene Tower 1 and this is the second tower. And there are, what are the challenges? Let us look into it. This is the backwater which is running. And the problem was that as per coastal zone management, if it is zone 2, they need only 10 meter setback. And if it is zone 3, they need 50 meter setback. So this building didn't have 50 meter setback and had to be demolished. All those buildings, same problem. So this is the tower, 2 towers, 116 floors building. And we have to bring it down. There are 40 odd houses, small houses nearby, very densely populated area. Another multi-story building of 10 stories next to the flat. Explosion has to be carried out without affecting nearby houses. The plan was to make the apartment collapse into the space between these 2 tower area. So this is where we wanted to get it done. So if you look in, this is the total residential buildings nearby. With Le Méridien had the building. This is the Le Méridien Hotel in Cochin, and their annex complex was just besides this. And this is the plan of the structure. I am skipping that. This is where the buildings were luckily founded on pile going up to 45 meter. And this is the structural plan. And look at the soil, very source sensitive marine clay with SPT value 0 to 2. So we were afraid of the heaving going to happen due to this impact. Luckily, all the buildings were kept in pile, which has gone up to a depth of 37 to 45 meter, resting in the dense sand strata. And this is the second project, which is the Jain housing project, which was of about, for the largest building, 4 lakh square feet of this building alone. Flat is surrounded by backwaters, has to be demolished, even while ensuring the rubble does not fall into the backwater. And if you look at the setback here of this car parking area, it was only 2 meters, and we have to bring it down without getting the spillage into the backwaters. And another small buildings also in the area, but fewer houses. The plan was to make flat collapse towards the eastern side. So this is the Jain coral cow. I'm skipping the structural aspects and the other aspect, which we'll share on another occasion. And this is the Golden Kylorum building, the smallest of the lot, but the toughest of the lot. So what was happening was that there is a Anganwadi located near to the flat, just 5 meters away, a 20-story multi-story apartment 10 meters away. It is feared that debris will fall into the backwaters and the area will be engulfed by dust after demolition. The smaller part of the building will be made to collapse towards the Thaikudam bridge and the larger portion towards the opposite side. So we have gone for a split technology here, where we are making one portion of the building fall on one side and the other portion of the building to fall on to the other side. So this is the area. You can see that this is the Golden Kylorum project, and this is the Hira apartment just 10 meter away, 20-story tower. And this is an Anganwadi building close by, and so many buildings nearby, and we have to bring it down. So this is the H2O apartment, a house at a distance of 1.5 meter away from the flat. Right next to that is the petrol house of Bharat Petroleum. The Tevara Kundanur bridge is at a distance of 10 meters from the front of the flat. Petrol, diesel pipelines of the IOC also passing through the underground in front of the flat. And it was so thickly connected. You can see the bridge here. So we had only this small portion where we have to bring the building down at a 36-degree angle on one portion and 47-degree angle on the other portion, and bring it down without creating damage to the surroundings. So let us look into what we did. So this is, you can see that. So this is the bridge which is running through. This was the apartment. This is the BPCL, this thing, and so much of petrol pumps and pipelines and oil and gas running across. So it was a big challenge. So this is the plan. And this is the structural framing plan, the shear wall, and all this building was designed and executed by us only. So this is the tower. You can see the bridge very close by, the pipelines running, and high pressure oil pipes, right, pumping oil from the ships to the BPCL refinery in Cochin. All those pipes are running through this. It was a major challenge for us to solve those issues. So this is the plan. Finally, we did a lot of homework, lot of design and debate, thanks to the wonderful team of Jet Demolition from South Africa, headed by Joe Brickman. We had a lot of discussion, hands-on for calculations, and finally we decided to bring it down. And these are the different lines where we are planning to do the blasting, and what is the load which is going to hit the ground, how we are going to control it was all worked in paper. And you can see that this was the planning. These are the primary blast floors. These are the secondary blast walls where we will be blasting the shear wall. And these are the different sequence of the blasting was also planned. And finally, we didn't want that to the building to come down together. It will be a split blasting. And that is the technology which we used in controlled explosion and bring it. And you can see that the heap is formed. Okay, the heap going up to 18-meter height was predicted. And this is the setback lines where we would like the material to come down. And that is why this thrust is not hitting the ground. We are able to bring in. So let us move forward. So these are the beams which were provided across surrounding the building in order to prevent the vibration getting transferred to the neighborhood area. And this was filled in. Beams were formed and protected in order to absorb the shock of the collapse. And these were the equations which we calculated. So there was a wonderful team comprising of the explosive department, pollution control board, engineering team to work out how to go about with that. We were all wetting their calculation. And this is the basic equation where we worked out what is the breaching load required and how the hole to be drilled. I have just put one case and how much the depth has to go, how to put the blast, what should be the drilling summary, how we will place the wire mesh and geotextile, and what should be the distance and how to drill the holes and how to put the what sort of explosive needed, how much is the explosive needed, and how will we control the delay. So if you look in here, this is 9 millisecond delay. This is 25 millisecond delay. This is the long delay, 200 millisecond delay. And again, this is a 6.4 second delay. Now we are moving from one phase of the building to the other phase of the building. And that is why the impact has to come down. The other has to, each time we are making the building to come down on a gradual manner. So this the building surrounding the entire area was assessed. Pre-demolition assessment was done by the Association of Structural and Geotechnical Consultants. All the buildings were mapped before explosion and after explosion to study what exactly has happened. And use only minimum charge weight of explosive to successfully achieve the implosion. And that is where the trick, as a structural engineer, we put more steel, it is more safe. But here what happened, if the explosion component is less, there will be failure. Sorry, I am not able, due to the scarcity of time, I am not able to show you the videos of failures which has happened. And if you put more, it will become an explosion and flying debris will go and it can lead to death of people. Remove all unnecessary structural elements to lighten the structure. Minimize ground vibration to eliminate damage to adjoining structure, minimize and control the spread of cementitious dust cloud, and designate a design footprint to collapse the structure within and design for a debris pile to work out. So this is the most important challenge, the touchdown vibration. When the building comes and hit the ground, you have to control the load. So we have about 75,000 ton, we removed the 30,000 ton, and we sequenced it such a way that each time when the explosion comes, it will be less than 1,000 tons. So
Dr. Joseph, you have 5 minutes more, please.
Yeah. So this is the computing formula for vibration caused by building. So this is the equations where if the velocity of impact is less than 35 mm, there won't be any damage. If it is 50 mm, there will be slight cracking per second. 80 mm per second, there will be cracking. And if it is more than 115 mm, it will be severe cracking. So this is the calculation which we worked out. And we found that the impact will go up to 265 meter if it is brought down all together. And this is the cases to 325 meter in case of giant coral cow, and minimum 35 mm meter per second will have from 140 to 180 meter team. This was the team which executed the job. And first phase was to involve the planning. And this is Joe Brickman of Jet Demolition who was doing that. And the phases were done there. And this is the pre-demolition work. We were measuring the ground building, assessment of nearby building, and you can see that accelerometers and sensors were placed. And I was talking about the pipeline where we have put in bags to prevent the impact directly happening to the pipe. And the team from IIT Chennai was brought in to measure the impact which is happening. So they used accelerometer and geophones to do that. And the structural engineering team assessing the building. And this is the layout where we put our sensors to measure what is happening in each cases. And here you can see that what is happening. And this is the video where during the implosion, what happened exactly. So that is how, if you see that one impact comes, then the next impact comes, by that time the vibration gets controlled. So by the time the next fall happens, it will be over. The next building will come, that is the millisecond delays, which we are imparting so that the weight hitting the ground is controlled and touchdown vibration can be controlled. So finally, on the day of January 11th and 12th, we brought the building down, and this is the buildings before, and you can see that building after. And this is, I will just share a couple of videos exactly of what has happened. So this is the Holy Faith building which was going down. So we will just skip this and we'll go to the this blast. This was one of the most perfect blasts which we had. So this is the 4 lakh square feet jet.
9, 8, 7, 6, 5.
And this was the last of the blast of the Golden Kayaloram. This is where we went for the split blast. So these are the after things what all do. And I just wanted to summarize in last 2 minutes. Law is above everything. Law needs to be enforced strictly on officials responsible for providing clearance, builders and contractors. Transparency of law is required. Authorities need to provide a clear picture of area under each zone. And it is always better to avoid creating a problem rather than thinking of a solution after creating it. The demolition apartment, which had with a span of 3 to 2 years was constructed. It was not done overnight. And people were residing in 8 years. There are 2 more important factors which we have to consider, the social and economic. As per the study of IIT Madras, the impact was equivalent to removing 8.1 square kilometer of mangroves, and everybody celebrated the demolition, but we never thought once about the families who were left homeless. There should be a provision for avoid demolition of 29,000 buildings already constructed at these zones by charging a penalty. It took years to build, but only few seconds to demolish. Let us learn from our mistakes. And this was the before and after. Some of the photos. This is the IIT team which was there. I just skip on the last minute with some photos. This is the structural engineering team who did the job. And this is how we did the activity, the protection work. The teams who are, this is along with the entire administration team who did the job. And finally, this was what it was before and after. Thank you very much. And I think I am able to finish on time. Thank you.
Thank you very much, Dr. Joseph. You have been perfect. You have been exactly within time, and you have taken exactly 25 minutes. Thank you very much for sticking to time. And also thank you very much for a wonderful presentation, which brought out the tremendous complexity in demolishing anything by the implosion method, especially the planning of the entire demolition process and subsequently the execution of that. I think it was a very exciting period for you. At the same time, probably a heartbreaking period also for you because you designed the buildings. But thank you very much. It brought out the entire subject of implosion. I wish we had an entire webinar on just this one subject. But thank you very much indeed for this. Okay. I now move to the second speaker of this evening, Mr. Sanjay Kumar Jain, who is the CEO of B&S Engineering Consultants based in Noida. He obtained his bachelor's degree in civil engineering from Nagpur University. Mr. Jain has his MTech degree from structural engineering from the University of Roorkee. Mr. Jain has 26 years. Could you please mute yourself, please? Mr. Jain has 26 years of rich and relevant experience in the field of bridge engineering, and over the years, he has developed expertise in all aspects of bridge design and construction. He has worked on pre-bid services to contractors, detailed design and construction of a large number of infrastructure projects like river bridges, flyovers, elevated metro viaducts and stations, railway bridges, and so on. He is a member of the Foundation, Substructure and Protective Works and Masonry Bridges Committee, B3, of the Indian Roads Congress. And he is also a life member of the Indian Association of Structural Engineers and the Indian Concrete Institute. Mr. Jain, welcome, and please present your presentation. Again, you have 25 minutes, and I will give you a slight warning at 20 minutes. Thank you.
Thank you, Dr. V.C. Rao, A very good evening to everyone. I'm going to present in this interesting topic of the demolition of the structure. That is a case study, which is demolition of a bowstring bridge, which is basically railway overbridge. It is why to demolish a bridge? The first question, and there could be so many answers. The first question is, the first answer could be the structure is old, it has completed its service life, or it may be functionally inadequate structure. The width or the loading or the vertical clearance required is modified after the construction of the structure. There could be a condition where the structure is unsafe. It is designed with a defected construction material, or there is a change in the loading pattern of the bridge for which it is designed, and there could be a hindrance to further development, like FOBs or ROBs, etc. Sometimes they planned with a different planning, and then later on, after 50 years or so, the requirement of that particular area is modified. So it requires that bridge is constructing a hindrance for the further development. So these are the conditions, and there may be a few more conditions in which a bridge may require a demolition. Some of the challenges faced during the dismantling. First one is the safety of the bridge itself during the dismantling, that it should not fall off in an unintended manner and dismantle and damage the structure adjacent to the this particular structure. Then second could be the safety of the personnel who are involved in the demolition and the equipment. Everything should be protected very well so that there is no damage to the person, life or property. There could be a damage to the nearby or passing by utility, like a road or a pipeline or a railway line or its users. So all the safety of all these items have to be ensured before the planning stage itself. And there could be a endanger to this property, adjacent properties and inhabitants. So all these things have to be protected. Then these are the safety concerns. Then there could be some administrative concerns, like availability of the space for movement of the crane and keeping the large dismantled part of the bridge. That is one challenge. Sometimes it is difficult to even mobilize the large capacity cranes up to the bridge site. Then there could be a mobilization of the high capacity cranes to site due to development happened after construction of the bridge. That before the construction there was nothing around, but after the construction of the bridge, since time has passed and that space is occupied by the inhabitants, so there is no or very less space available for the movement or mobilization of the crane. Then the high capacity equipments have to be mobilized to the site, and this could be a difficult activity for far-flung sites, especially. So these are some of the challenges being faced by the dismantling agencies. Some introduction about this particular bridge. So this is an ROB, road over bridge at kilometer 948 on Kanpur Prayagraj section of North Central Railway near Fatehpur station in the state of Uttar Pradesh. The bridge was constructed with a span arrangement of 22, 60 and 38 meter. 22 and 68, 38 meter spans were in cast situ girders, concrete girders, whereas the central span 60 meter was a bowstring girder, which needs a dismantling. The deck width of the bridge is 12 meter. It's a bowstring arch type steel arch with cast in situ RCC deck. There were two Indian Railway tracks which were operational and carrying a very high amount of traffic through because it is connecting Delhi with the Kolkata. And there are two DFC tracks which were available for the immediate operation, but not yet under operation. The track was electrified. Both the tracks were electrified, and the location of this particular ROB is on National Highway number 232 on Raebareli-Banda section. The project was owned by National Highway Authority of India, NHAI, And the dismantling agency involved was Central Dostroy India Private Limited. The dismantling consultancy services was provided by BNS Engineering Consultants in association with BM Associates. The scheme was finally accepted and approved by North Central Railway, the owner of the utility service, of course, by National Highway Authority of India. And then the maximum weight of an element being lifted here was 95 ton. The total weight of the deck slab to be removed was 360 ton, and the weight of the structural steel bowstring arch was 235 metric ton. There were two 500 ton capacity cranes were deployed for movement of the main elements, and there was a small crane for doing a small lightweight activities. The distress to the ROB was noticed in June 2019, and the dismantling was completed in January 2021, just 6 months back. And the total time taken on site was only 8 days. The rest of the 1.5 year was the delay due to the administrative reasons and preparation of the schemes, planning and approval from various agencies of proof consultant, then railways, and then CRS sanction. All these things took time to the tune of this 1.5 year. This is the general arrangement drawing by which this bridge was constructed. The central span was 60 meter. Then there are 2 side spans in concrete. This was the JD approved by the railway, and based on which the bridge was constructed. Just after construction, around 3-4 months after the bridge was opened to the bridge, there was some distress observed, and all these things happened. This is the crane which was deployed for the movement of various elements of the bridge. This is a 500 ton capacity train. This is the completed bridge just before the dismantling. It is just when this distress was noticed. This is the photograph taken at the time when first distress was noticed. The traffic was closed. Trains were running with caution at that time. This is the closer view of the span, affected span. This is the location of the defects. The 3 hangars marked here were there was distress observed at these 3 locations. One can see that the joint between the hangar and the bottom cord was opening at the earlier designated 3 locations. Immediately on noticing that there's a distress in the bridge, the immediate action was taken by the National Highway Authority of India through the EPC contractor that to support the underside of the bridge by providing cribs so that no untoward incident happened. Immediately, the cribs were deployed at site, and bridge was made safe so that it doesn't cause any catastrophic collapse. This is the bridge just before the construction, just before the demolition starting, which means existing bridge. There was some preparatory works taken care during the before this dismantling, that the entire site of the bridge was barricaded for any trespassing of living being, either human, animal, or anything, and clear the infringement for the staking of the material or temporary arrangements, because there was not enough space for the movement of the crane. So the bridge deck of the adjacent spans was being cleared for making the storage of the dismantled material. The tracks were protected as per the rules of the Indian Railway PV manual. Before starting any activity of the dismantling, CRS sanction was obtained for the dismantling as well as erection of the temporary structure near or over the adjoining railway tracks. As per the SOD, a 3.5 meter clearance from railway track was maintained, though as per SOD, the requirement is for moving objects that and for stationary object, it could be 2.5 meter. But as a abundant precaution, it was decided to keep a 3.5 meter clearance from the even stationary objects also. And all activities over and around the tracks were performed under the traffic and power block of railway, because it's a electrified track. The temporary grips or staging were provided under each hanger wherever possible. Wherever the track is lying below the hanger, so whatever was the nearest possible location, the grips were positioned. And on the moving trains, a restriction of non-stop and 30 kmph maximum speed was imposed. And the capacity of the cranes as planned was confirmed by the operator, and operator was brought to the site before any operation was started, and confirmed that the movement of the crane and all the things which are planned can be done at the site without any hindrance or failure. Then, first of all, the crash barrier, hand railing, footpath were removed without any requiring traffic or power block. Then excessive wind speed of more than 30 kmph, it was decided that no critical activity of lifting of any part of the boosting will be undertaken, because that may be there may be a unprecedented movement of the hanging part during that time, and it may damage the remaining of the structure. And strengthening of the damaged location of the structural steel was done, so that the members are able to take the load considered during the dismantling. Then railing and the crash barrier of the minimum 30-meter length of the approach span on either side was removed, so that it creates a platform for supporting the dismantled portion of this deck slab. And stools were placed at the predetermined locations, so that the loading on the existing bridge can be placed at the designated place only. It is not placed at any other location, for the safety of the adjacent spans which were not to be demolished. And the deck slab was cut at the designated locations in the adjoining parts as per the drawings, so that removal can be made. And the cutting was done by a concrete saw cutting machine, though it was planned for a wire cutting machine also, but finally it was adopted to go for saw cutting machine, and concrete as well as steel. And there were some grips which were placed on the DFC tracks which were non-operational. So for those tracks, ballast was placed between the rails and on the shoulder to cross the crane from one side to the other side of the track during the short power and traffic block. For the safety of the structure and the personnel, the complete barricading of the upper level road was done, except site personnel. Nobody was allowed to enter into the site. Then strict barricading of all around site was for entry of after the entry of the required machinery to the site was done, so that no trespasser can enter into the demolition site. Then procurement of necessary test certificates of crane and other equipments involved was done by the agency. Then all ground personnel were made aware of the safety issues. Every personnel was guided to wear PPE kits. Then activities being performed under traffic and power block of railway need to be planned in a conducive manner. So in case of any unexpected time overrun, then prior intimation and action must be taken. This was the special instruction given to the site people. This is the structure after erection of the cribs, just before the starting of the demolition. The entire structure was divided into three parts, as being shown in here in three colors. The first part to be dismantled was decided as per the railway as the part B, the central one, and then part A, the left one, and then part C, the right one. This was decided by the railway, though we planned earlier that we go firstly with the portion over the railway tracks, so that once the track, the portion above track is cleared, the problem to the railways is minimized. But railway people insisted to go for the part B first, and then part A and then part C. This is as per their instructions. Then every element to be demolished was marked with a distinguished number, like external girder, cross girder 1, then bracings, top bracings, bottom bracing, hangers. Every member was given a different nomenclature. This is the first stage of demolition, start of the demolition. Then first of all, place the crane at the desired location for removal of the upper portion. Firstly, upper portion will be removed. So for removal of the upper portion of the arch and hangers of the central portion part B, then hold the upper portion of part B and cut the arch of part B along with the hangers at these 3 to 4 locations. First is here, second is here, then second hanger, and then there. So after cutting the structure at 4 locations, and the cross girders, top cross girders, etc. Firstly, top cross girders were removed, and then the cutting of this arch beam and hangers was started, and so that both the girders, left side girder and right side girders, GR1 and GR2, are independent, and they are cut and then lift by the crane, and upper portion is removed with the help of crane and kept on the ground, because both the GR1 and GR2 are separated by after first cutting the cross girders. So both are separated and they are placed at the ground and disposed of. These are some of the photographs of dismantling of the in the right photograph, cross girders are being removed. In the left one independent cross girder is being removed. And then this is one part, the part B, with one arch and part of the arch and 2 hangers is being removed. As you can see that both the GR1 and GR2 left and right girders are being handled separately. Next stage is after completion of all activities of part B. Now place the cranes for removal of the part C in an designated manner and at location. So for removal of the upper portion of arch and hangers, hold the upper portion of part C and cut arch of part C and hangers B6 and B7 from bottom, and lift and remove the upper portion assembly of part C with the help of crane and place on the ground and dispose of. Then cross the cranes across the railway tracks. So there were 2 tracks. So these are the 2 tracks, operational railway tracks. So now the crane has to cross the railway tracks and brought on the other side, and within the traffic and power block of 1 hour, and then place the cranes at the location for removal of upper portion of arch and hangers of part A. Hold the upper portion of part A with cranes. Cut the arch in a similar manner, all 3 hangers and the bottom portion of the arch connected with the bottom cord. All these things have to be cut along with the cross bracings, cross girders, and so that both girders get separated from bottom and top, and then remove the part to the ground and dispose. After complete removal of the upper portion, now only bottom cord and deck slab along with the cross girder is pending. So after complete removal of the upper portion of arch and hangers, place the crane at the designated location for removal of lower portion of having cross girders and RCC deck slab for part A, and provide cross beams, we call them spider beams, under the lifting portion of part A and attach with the crane sling in a balanced manner, so that the CG of the element to be lifted and the crane hook remains at the same location. So lift the deck slab with cross girder of part A near expansion joint over 10.25 meter length. So the total length of the part A is 24.5 meter, but out of only 24.5, 10.25 meter is being lifted, because the weight, there's a limitation of the crane that it cannot lift with the boom length and radius, it cannot lift more than 95 ton segment weight. So to reduce the weight of this 24.5 meter length, it is the deck slab is cut into two parts. One is 10.25 meter, and then the 15.1 remaining 15.1 meter. So that's why this is divided into two parts. For this 10.25 meter, and place it over the adjoining span of, and the total weight of this element was 75 ton. And then both the cranes, since both the cranes are holding a single unit of this 10.25 meter by 12 meter wide deck, so they have to work in unison. So the crane operation has to be very carefully done. Otherwise,
Mr. Jain, you got 5 minutes more, please.
Sure, sir. These are the photographs for the dismantling of this 10.25 meter portion of the deck slab. After removal of the 10 meter length, the remaining 15 meter for the removal of remaining 15 meter length of the part A, place the cranes at the desired location for removal of remaining part, and provide spider beam 1 under the part A. One can see the spider beam is visible in green color. And attach the with the cranes link in balanced manner, matching with the CG. Then hold the spider beam 1 placed under the part A with cranes, lift and remove the lower portion assembly of part A with the cranes, and place it on the approach span on stools already placed, and dispose of the demolished material and remove the cribs CC1 and CC2, so that this place is now clear of the any other activity. This is removal of the deck slab along with the cross girders. This is removal of that 15.25 meter of the slab along with full 24 meter length of the cross girders. Sorry, bottom part. And cross cranes across the railway tracks. Earlier we were working on the left portion of the railway tracks. Now the crane has to move back to the right side and cross the cranes across the railway tracks with traffic and power block. Place cranes at location for removal of the deck having bottom beam, cross girders, and RCC part of the deck slab. Then provide spider beam 1 under the deck slab and attach with the crane sling. Hold the spider beam placed under with the cranes. Lift and remove crib CC3 and CC4. So under this lifted position of this element B, crib CC3 and CC4 are removed, and then this element is brought on the ground itself. So because there was no other place to keep this 15 meter long element, and cranes in position, because cranes cannot move lifting the this 95 ton block of the concrete and steel, and then dispose of the material from the ground. And then in the similar manner, place the cranes at the location for removal of the deck slab, having cross girders and deck slab for part C. Provide spider beam under for lifting of, again, this is a longer section of 20 meter. Again, 5 meter portion has to be removed first, and then the remaining 15 meter length portion in a similar manner. These are the details of these spider beams. So first spider beam is for the removal of this 12 meter wide deck, and the spider beam 2 is for removal of the short span of the deck slab, 10 meter and 5 meter, as mentioned earlier. Just some of the photographs for removal of the deck slab. This is with spider beam 2, short length. This is the picture of the bridge almost after the demolition. Both girder G1 and G2 being lifted simultaneously. And finally, conclusion. Dismantling of a bridge superstructure is much more difficult than its construction, as told by Dr. Anil Joseph, that once who has created a structure, it is very, very difficult for him to demolish it, dismantle it. And intelligent and timely planning is the key to the successful completion of difficult task of demolition of a bridge superstructure. Then adequacy of partly demolished structure must be ensured under every stage beforehand, so that there is no untoward incident happened during the dismantling process. And policy of zero tolerance on safety must always be adopted in such an activity. Then all ground personnel must be made aware of the safety issues during the this demolition process, what could happen. Thank you. Thank you.
Thank you, Mr. Jain. You too have stuck to time exactly to the dot. Thank you very much indeed for maintaining the time. And your presentation was also a very big eye-opener for all of us. And it also brought, it was a very lucid presentation, very clearly showing how the dismantling was done. I think we've all learned a great deal from your experience. And you have also reiterated what Dr. Joseph said about the meticulous planning that is required, and the very careful, methodical way in which the dismantling has to be done. It requires a tremendous amount of engineering planning, pre-engineering planning actually. And in your particular case, working in the very narrow time slots given by the railways, I know how difficult it is to work with the railways, especially on an operational line. So I think it has been a magnificent achievement that you've done. And the first part of it, of course, is why a perfectly good bridge had to start failing in the first place, which required its entire removal, which is a pity. But that is how life is, and we need to continue with this. Therefore, people like you and people like Dr. Joseph and many others like him are also greatly required experts to ensure that buildings that are built are also brought down safely. I think that's a very, very important thing that we have learned today. Thank you very much indeed, Mr. Jain. We now go to the third speaker, who is Mr. Rajbhoj, and he is Assistant General Manager Designs in Afcons Infrastructure Limited. And Mr. Rajbhoj has obtained his bachelor's degree in structural engineering from bachelor's degree in civil engineering from Government Engineering College, Aurangabad, and master's degree in structural engineering from VJTI, Mumbai. He has more than 20 years of rich experience in design of permanent bridges, enabling structures, and construction methodologies for bridges. He is currently working on a landmark project such as Mahatma Gandhi Setu, Patna, and the Chenab Arch Bridge, Kashmir. He is a chartered engineer and fellow member of the Institute of Structural Engineers, Institute of Engineers, India. In fact, this is a particularly interesting presentation for me personally, because I have traveled on this bridge any number of times from Patna to the other side on my way to Darbhanga and to Madhepura. And it has always been a misery because the highway, the bridge superstructure was in such bad shape that in several parts of the bridge, only one lane was operational, and therefore it could take anywhere from 2.5 to 3 hours to just cross the bridge from one side to the other because of the massive traffic jams and the restriction in the lane width. So I now hand over the floor to Mr. Rajbhoj to speak on the rehabilitation of the MG Setu Bridge in Patna, and I'm sure it's going to be a very, very interesting session. Over to you, Mr. Rajbhoj.
Thank you, Mr. B.S. Rao. Am I audible? Yeah.
Yes, please.
Yeah, today I'm going to speak upon the rehabilitation of MG Setu Bridge Patna. Now, this is a 5.575 kilometer long bridge, 4 lanes over River Ganga on National Highways 19. So, brief about my company, just a short brief introduction. Afcons is a premier construction company and is renamed as Afcons in 97 and taken over by Shapoorji in 2000. Afcons has bagged many international awards. It's the Best Employer Award in Africa, in Bhutan, and recognized as a top international construction company, larger category. Now, we have won several awards for Rohtang Tunnel, like the Best Construction Project by CIDC Vishwakarma Awards, National Excellence Awards by MORTH, 6th Atal Markamoni Awards, and 10th Construction Week India Awards. The replacement of this MG Setu bridge has also won an award, in spite of it's not yet been constructed. The first carriageway is open on the left-hand side, but on the downstream side, it's still going on. But it has won a Best Construction Project at CIDC Vishwakarma Award 2021 and Excellence in Innovation in National Highways for MORTH. So these are the key stakeholders of MG Setu Bridge. Employer is MORTH, Ministry of Roads and Transport Highway, Executive Engineers RCD, Patna, Bihar, Authority Engineers TPF in association with Chaitanya. Consultancy contractor is Afcon Simos JV, design consultant Spectrum, proof consultant Stratcon, safety consultants Almonds, and independent design audit was done by Professor Chan. Now, these are some of the very challenging issues and faced during the deconstruction of this superstructure for MG Setu Bridge, challenges in construction as well as in designs. These are the basic topics that we are going to cover while going through this presentation. Design construction, design check for substructures during the construction stages when the superstructure is being dismantled. The substructures were checked for different construction stages. The design check for ballast cantilever bridge during dismantling, and then the erection of steel superstructure, and the substructures and foundations were checked for the new superstructure load. Design of erection systems for new superstructure, that is steel truss on land and waterway spans. So this was the condition of the bridge when we got the tender. The two arms of the ballast cantilever were having a substantial difference of 150 mm to 300 mm. This is the upstream side of the bridge from Patna to Hajipur side, and the vehicle moving from on this were literally flying on the other arms of the ballast cantilever, causing a lot of stresses and fatigue. So this bridge has to be definitely brought down because there was safety issues involved. One span was already dismantled on the upstream side when the tender was awarded to us. There were external cables placed inside this box girders of a superstructure because the authorities tried to bring back the deflections to its original shape by providing this external pre-stressing cables. There were a lot of external pre-stressing cables, so during dismantle, this has to also to be taken care of. So this was the total scope of the projects from Patna side to Hajipur side. There were land-based spans, there were intermittent spans. These were either wet or dry, but it was, it was having a little water. And then there was a perennial water spans, which was having a deep waters. And this is on the Patna side. So each span was 117 meters long. This was 5.5 kilometers from Patna to Hajipur. And we divided this bridge into three spans, like a dry spans, dry wet, that is intermittent spans. The dry spans were 26 number each carriageway. Now two carriageway becomes 52 numbers. Then dry wet spans were 10 numbers on the upstream side, and wet spans were 10 numbers. So these were the general arrangements that we segregated for this dismantling purpose of this Patna bridge. We'll talk about the construction stages that we have established during the construction stages that we have established for the dismantling of this bridge. So these were the two carriageways. This was upstream side carriageway and this was downstream side carriageway. This was the condition of the bridge before the start of the projects. Then we dismantled the upstream side first because the traffic was still moving. So all the traffics were diverted towards the downstream side. And this total upstream side superstructures were dismantled, and then there were it reached to such a level. Then we have to construct a new pier cap. Then these protruding bars inside these piers were exposed to the development length, and then the new pier cap was cast. And and then we started constructing. We wanted to construct a superstructure on the upstream side. So what we had that, if you see the previous slide, the total superstructures were concentrated to the pier. But when the new superstructures was going to be constructed, it was very eccentric. So when we calculated, the inner face of the piers were giving very high tensile stresses, and the crack widths were more than permissible limits. So what we tied these two piers together with the stressing bars to bring back the stress levels to the required to the desired level before constructing this superstructure. So after doing this, we constructed a superstructure on the top of the upstream side. And when this is completed and commissioned, now this is the stage, current stage, rather this is the current stage, then we dismantle the downstream side. So downstream side has been dismantled now, and traffic is moving on the upstream side. And new pier caps are being built over here. And after building the new pier cap, these two pier caps were tied together, or rather the development bars of the upstream sides were embedded inside the downstream side, and this forms a portal action. And then we remove this temporary pre-stressing cables. You see here the temporary pre-stressing cables were removed, and then we construct the downstream side. So this was the general construction and deconstruction construction sequence of rehabilitation of MG Setu Bridge. And during dismantling, there were safety platforms laid all around the pier cap for walking of the people, then stressing, then chipping of the concrete piers to protrude the development rebars, tying of the reinforcement arrangement for formwork, casting of the new pier cap, and also tying and stressing of the Macaulay bars that we have discussed. This was the construction of pier cap grounds supported arrangement, conventional method of casting the pier cap on ground supported arrangement. And as I discussed, like 4 numbers of pre-stressing bars of 750 kilonewton each, that is 75 ton each, that 4 bars. So these were tied together to keep this stresses of the inner face of the pier within the limits. Now, this was the dismantling proposal that we have received during the tender document. In the tender documents, it was like a launching girder spanned over 2 spans. That is, this is around 240 meters from here to here, and from there cutting of the segments where segments were cut and lowered onto the barge or a truck on the land spans. So on the water spans it was lowered on the barge, and on the land spans it was lowered on any trailer. So this was the arrangement given, and we have studied this proposal. The steel requirement was approximately 1600 metric tons. Design and engineering drawings of this overhead girders were taking 2 months. Time for fabrication, procurement, erection of this truss was taking 8 months, and time for dismantling around 1 month. So this was a very expensive exercise. What we did is for the land span, we used a jaw crushers. We used a jaw crushers for the land span, and for the cantilever span in water, we use a cantilever gantries for water spans. So these were small gantries. It was only hardly 35 metric tons as against the 1600 metric tons that were assessed in the tender. So 1 gantry was 30 to 35 metric tons, and 2 gantries were 70 tons. So 4 or 5 sets, 4 sets we have produced on the site, and it was still much lower than the tender proposal. So this was a basic calculation that we did. The tensile stresses are developed, and the on the top of the top fiber of the superstructure. So this P by A, the pre-stressing force into the area of cross section, then the eccentricity onto Z top. Then this is the dead load. Now these are all causing a negative moment because it is acting as a dead load on the cantilever arms of the balance cantilever. So this was giving a negative stresses, and this has to be minimized as much as possible. And there was a derrick crane load which was also giving a negative stresses. So this we have assessed, and a very simple formula. This is the P by A and M by Z. What we did is to limit the negative stresses on the top fiber of the superstructure. We reduced the SIDL footpath loads before actually dismantling the superstructure. We have removed first the SIDL load, footpath, and crash barriers. We also removed the wearing cord by excavators. All the wearing cords were removed from the top of the superstructure. We also removed all utilities and cable through widths with the help of cranes. So this was reducing all the loads from the superstructure, and the stresses, tensile stresses, were limited. So this was the calculation that P by A, M by Z we did. We saw that for all stages, there is no tensile stresses developed at the top fiber of the cantilever arms of the superstructure. Now these are the jaw crushers. We placed jaw crushers from both sides. It was symmetrically dismantled. I mean, both jaw crushers were moving in, jaw crushing all the segments stage by stage, and these were moving exactly parallel to each other. That means there were no eccentric forces which would cause an undue induced moments in the foundations. And these towers, if you see here, these towers were just placed below the superstructure. It was not touching to the superstructure. We have just kept a gap of this between this tower and the superstructure. because we thought that there might be any catastrophic failure, because inside of the cables inside the webs, the conditions were not known. So we just kept it for the safety of the people working underneath of this superstructure. Okay, so the jaw crusher was a very fast dismantling object, and the jaw crushing of the superstructure was very effective, and we achieved around 6 spans in a month. Means this we consider as a 1 span. This is the photographs of the jaw crusher, and as I've already told that these were the temporary towers, and it was not touching to the soffit of the superstructure. This tower was having some gap, and we just kept it for the safety purpose, because we really didn't know how the dismantling behavior would take place. And you can see here the mist blower when we were dismantling, and the other side of the carriageway was having the moving traffic. So there was a lot of dust and debris flowing around. So we provided this mist blowers. As soon as the jaw was crushing, this mist blowers used to blow water particles on this crushed concrete, and the dust particles were brought down. It was not flying around and causing any nuisance to the drivers on the downstream side carriageway. On the water spans, what we did is we assembled a cantilever construction gantries. As I've told you, each gantry weighed only 30 metric tons. The rear leg of the gantry was tied to the previous segment and anchored it properly. And even some cantileges were laid so that the factor of overturning moment was greater than 2. And this was 30 metric ton. And this was designed to carry a load of 80 metric ton segments. So these segments were cut in 3 meters length, and we found out that it should be less than 80 metric tons. We calculated the weight of the segments, and these were moving symmetrically, cutting the segments and moving behind. This was the program that we done, just like construction programs. We did this deconstruction programs, and this gantry movement of the gantry was restricted to the difference of 1 segment dismantling, so that there should be no unbalanced moment on the piers. And like we had tied towers beneath the superstructure and not touching the soffit, we have also did some temporary stressing at the top at the water spans, because we were not able to provide any towers at the bottom for water-based spans. And we did only for this 5 spans, because we were actually seeing how the behaviors of the superstructures would be during the dismantling. So we tied it for initial 5 spans only, and water spans, 1 or 2 water spans, so that it doesn't give inappropriate behavior. So this is the dismantling of the water spans being done. And these are the photographs cutting the segments and moving back. And you can see the carriageway on the right-hand side or the downstream side is still having the traffic moving around. The gantries, and after cutting and lowering on the barge, the gantries were skid behind, and then the next segments were cutting was taken place. Now we were marked the segments, and the segments which were very big, which was crossing 80 metric ton for the 3 meters length, we have cut it into half. I mean, we cut those larger segments in 1.5 meters length. So we saw that the weight of the segments, cut segments, should not exceed 80 metric ton. That was what the capacity of the gantry was. So this is on the water-based span. You can see a barge is flowing behind, floating below, and here on the land-based spans, it was lowered on the trailer, so or on the ground and then taken over on the trailer. These were basically the intermittent spans, and these were having water sometimes and sometimes dry, but we could not move the jaw crushers here. The jaw crushers were only used for the land-based spans. The intermittent spans and the dry spans were used using the cantilever construction gantries or cantilever construction gantries. So lowering on the barge, as I've told, this is lowering on the trailers, and this is the cut segment photographs. Now, pierhead segments, what we did is, like, we were not having this enough gap to place the cantileges, so we tied these gantries together for dismantling the segments very near to pier heads, and this tied, and then we lowered both these segments simultaneously so that there is no unbalanced movements on the gantries or on the piers. Then after the deconstruction, then new truss was designed. There were two grades of the truss that were designed. One grade was with FY 485 grade that was designed by Spectrum design consultants. And then there was another grade which we have used for the construction of steel superstructure, that is FY 410. That design of the truss was done in-house by my team. And these are the load factors and combinations that we have used to design the superstructure of the steel superstructure as a replacement of the superstructure for ballast cantilever. So this is now demolition of the spans I have already talked about. But as Mr. Sanjay Kumar Jain has said, like demolition of the superstructure is much difficult than its construction. So the difficult part was over, and then we started the construction of the new superstructure, that is the steel truss. So on the land and intermittent spans, we did it with the ground supports. For intermittent spans, what we did was we did some ground improvement for crane to move. We did some filling works there. We did some compactions, and the ground supported arrangement of the trusses were done. And we erected a span with the bottom cord first, then the bracings, and then the top cord. So this is the finished span on finished truss on the land or intermittent span. This is the as I've already told, you can see here the intermittent spans. There were some waters, but we have to fill in, and the river Ganga was very unpredictable. The flow was sometimes very high, and sometimes we used to get a good sand. Good soil. So, I mean, that is how it was. But when it were intermittent span, there were some filling done and compaction done to lay these trestles and foundation, and it's precast foundations. Now, cantilever span erections in the water span, what we did is we did it with the balanced cantilever method. And you can see top hands will get some tensile forces, and the bottom, the compression. And there was an anchor span in middle. So this is how the anchor span was done in the water, and we drill these piles to the refusal, up to the refusal, and then we on-site bracings, welding of on-site bracings were done, and then the anchor span was erected here. So this is how the anchor span was erected, supporting on the liners which were drilled inside the river beds. And this is how the photograph of the liners, and you can see the construction and on-site welding of the bracings going on. And you can see here the pier cap construction in the land. There were trestles placed on the ground. But what we did here is we drilled a liner up to the refusal to support this formwork of the cantilever pier cap.
Mr. Rajboj, you have 5 minutes more. Please.
Yeah. So this is how it was done. And then there's the ballast cantilever works which were being carried out after the construction of this trestle. The bottom supports were removed. And this is a link member to tie this together during the ballast cantilever. This is the link member. There is a buffer slab for taking the compression. So this is at the bottom. This is the anchor span at the left side, and this is the new construction. So buffer slab and the link at the top to take the tensile forces. And this is how the construction commences. So this is the top tensile. This is a temporary member, and the construction begins from here on both sides. This is how it was constructed in water. You can see the crane on the floating barges, and it was feeding this one by one segment of steel members. And this is how we constructed the superstructure in the water by balanced cantilever method. This is the progressive construction photograph that we have seen. We have did this construction of balanced cantilever progression method, and using each construction stage we are using in the software side, and we were getting some values of deflections and camber values, so that we monitored on site that it achieves the exact camber on site. And we saw that this cantilever could span up to 103 meters, 104 meters, and we still have to reach 117 meters. So we placed one temporary support here. Because of the wind load, it could not span up to 117 meters, because here we were developing some very heavy stresses at the ends. So we placed one temporary support, and up to here we supported, and then the other part of the 13 meters were constructed independently. So this is the photographs of the constructed bridge by balanced cantilever method. And this is my presentation. I have got one small video if I can share with you. Is it visible? Is the video visible? Yeah.
No, the video is not visible.
Video is not visible, Shashank.
Not visible.
Okay. I'll just. One minute, I'll just share it. Is it visible? I don't know. Whether is it visible?
No, it is not visible.
Okay.
You have to open the video first before sharing.
Okay. All right. I don't know. I'm unable to share this video right now.
You still got 1.5 minutes.
So possibly I may not be able to share because this is around a 10 minutes video. So that is the problem.
Oh, okay. Then you'll probably have to conclude, Mr. Shashank.
Okay then. Okay. Thank you.
Okay, sorry we are unable to see the video. We have missed that, but thank you once again for sticking to time. And this was a different kind of project. It was both demolition as well as reconstruction, and it was a very, very interesting project that you have done. And of course, now the bridge will last for a very much longer time. So, ladies and gentlemen, we have seen 3 different projects, 3 different types of demolition, and all of them have been very, very revealing and very educative. And I thank all the 3 speakers for their wonderful presentations. Thank you all. We now have a short panel discussion for about 20 minutes. And the panelists will be the 3 speakers who have just spoken, and Dr. P.R. Swaroop, who is the Director General of CIDC, as I mentioned before. I now have the pleasure of introducing Dr. P.R. Swaroop. Though truly speaking, he doesn't really need any introduction to the civil engineers of India. He is so well known. Dr. Priyaranjan Swaroop acquired his BTech degree in 1975 and thereafter proceeded to serve the Indian construction industry. He later acquired his PhD degree from Rajiv Gandhi Technical University, Bhopal, and Dr. Swaroop has served with several prestigious domestic and international consultancy and construction companies over 2 decades, acquiring vast experience in engineering designs, construction management, project exports, technology transfer, and regulatory issues. Dr. Swaroop joined CIDC in 1996 as its founding director and rose to his present position as the Director General. In CIDC, Dr. Swaroop has rendered unparalleled human service to the improvement, growth, and development of the Indian construction industry, who have to be very grateful to him for all the efforts that he has put in. Dr. Swaroop has served as member secretary of the Working Group on Construction and is a member of the working groups on hydropower, surface transport, and housing for development of the 10th, 11th, and now the 12th national plans. He also serves as a member of several working groups of the UN Commission of International Trade Law and is currently president of the International Council of Consultants. Dr. Swaroop is a fellow of the Institution of Engineers, honorary fellow of the Actuarial Society of India, fellow of Institution of Surveyors, the Indian Society for Trenchless Technology, and serves on the boards of several institutions and corporate houses. I have great pleasure in welcoming Dr. Swaroop as a panelist in this important webinar. In fact, it's a very nice webinar that we had, which the IAS Trustee has organized, and not the usual one. So, Dr. Swaroop, may I now request you to take over and kickstart the panel discussion with your observations and comments that you might have. Over to you, Dr. Swaroop.
Thank you, sir. It is a pleasure being here and a great honor also. As a matter of fact, just to give you the preamble, I snatched this opportunity myself on my own volition and spoke to Mr. Bhaumik when I saw the banner for this particular event, because demolition is something which is very, very close to my heart, and for quite some time, I had been thinking of really pushing it as one of the policy matters that need to be adopted on the national scene for that matter. There is a bit of a historical situation and there is a bit of a contemporary situation which which kind of prompted me to come and participate in this particular deliberation. And I thought I must volunteer, and I asked Mr. Bhaumik to bring me in. And thank you so much, Mr. Bhaumik, Mr. Rao, and Mr. Manoj. It has been good to be here, and I really enjoyed all the three presentations. Excellent presentations, I must say. Actually, my first encounter with the demolition and official demolition, it started way back in 1983-84. And this was the time when, of course, we were just on the spree of constructing many of the infrastructural projects in the country. Those who were there, and I'm sure Mr. Rao would recall and remember that in 70s and 80s, we had suddenly embarked on setting up many, many ambitious projects which made India what it is today. On the power scenario, you had almost like 5 super thermal power plants that were being set up by National Thermal Power Corporation. On hydroelectric scene, there were a number of hydro projects that were mooted, and they were the execution started in right earnest. And several things were happening, but most important thing, and that's where I came into this demolition situation, that was actually the fertilizer production. You would recall that at that point in time, Government of India decided to have number of the fertilizer plants. And especially this was the time which was coinciding with the HBJ pipeline that was being laid, where the Bombay High extracts were being evacuated. Rashtriya Chemical Fertilizer, which was basically a kind of offshoot of Fertilizer Corporation of India, they have their oldest plant in Chembur, in Bombay. And I was actually working on a number of projects in Bombay at that point in time, running the show as the project manager. And this was the time when RCF invited me, and they had a very interesting issue which opened up the new vistas. And they said, we have a urea storage silo. It was a horizontal silo, if those of you who have seen the fertilizer plants, and I'm sure many of those would be. And the problem was that including the kind of inclement weather conditions, there was rusting that has set in, and that particular silo was almost like on the verge of collapsing. And they wanted that right in the middle of the running fertilizer plant, they wanted to demolish the structure because Chembur by then was getting populated and there wasn't enough space there for expansion. Later on, RCF decided to go and take up the land near Thal and Vaishet, which is very close to Alibag, which has become a kind of a holiday place now. Those days it used to be a small village, actually, fisherman's village. So they wanted this particular silo to be demolished. And they said that you keep talking about the new technologies and things like that. And I was interacting with them off and on because we were also doing quite a few things for RCF otherwise. So they said that we now want to demolish this whole thing. And this is a working plant. So you have to make sure that nothing is disturbed and the whole thing is basically demolished. Of course, in those days, demolition meant for anyone to have this, the crane, and where there was this hammer that was hung, and you go on hitting the damn thing and break and demolish the whole stuff there. But the chairman and managing director, he said, no, I want something which is far more scientific and far more convincing to me. And this whole thing has to be done in a pretty quick time, very little time. So we started searching, and as the things were, there were absolutely no knowledge or no understanding of systematic demolition. There was one more fact, that we had not constructed so much of the country which we have now. And this was probably one of a very peculiar situation where this structure was to be demolished. So searching people everywhere, and especially talking to my London office, we came across the information that there are only 5 families in whole of the Europe who know exactly how to do systematic demolition using the explosives and implosion or explosion, whichever way it was. But they were the only ones who do. And it was only Glasgow University, where one of the family, head of the family, he was accorded the status of a professor, and he was teaching the demolition engineering in Glasgow University. So I landed upon his doorstep, requested him to come in there. And then, of course, the rest was history, where we brought him to India, and then he demolished that structure. And 13 seconds was the total time when the whole job was done so neatly. Beautiful job. And the whole structure came down, no dust, nothing. Everything was as it just sat down. This was the beauty. And when I started understanding what exactly are the kind of things that he was doing, I started my career as a structural engineer. And then he told me and taught me as to how the reverse engineering is done, where the weak points were identified, the charge was calculated, the delayed explosion was designed, and accordingly, in about 12 to 13 seconds, the whole structure came down. Of course, as the tradition was, nobody is very sure when the demolition takes place. So he had put a cross there. He had offered his prayer before, the plunger was pushed, and then the structure came down. So, because he said at the end of the day, I do not know what might go wrong, and it could be the act of God for that matter. So let me make the God happy for that matter. That started my first introduction with demolition. Then, of course, I had been toying with this idea as to how exactly can we make it a bit of a formal situation, because you all know that from mid-80s till date, we have constructed so many assets in this country. May they be the industrial plants, may they be the housing, both for the institutions as well as residential, and highways, bridges, airports, you just name it, everything we have constructed. Matter of fact, when I take stock of the things, I have absolutely no hesitation in sharing this with you, that what we have constructed in last 25 years, can you just hold for a moment? Mamta, please shut this door. So in last 25, 30 years, we have constructed so much that probably in last 5,000 years we have not constructed. Now here comes the contemporary situation. Contemporary situation today is that we have much of the redundant structures available. Just to give you a small idea and just one wee bit of the stream in construction, let me tell you today, according to our CIDC estimates, we have almost like 25 to 30 billion square foot of constructed areas right in the city centers and the urban centers. Almost 5 to 7% of this particular lot is really worthy of demolition. It should not be there, because this results into man-made disasters. The buildings collapse, and those who have been working in Bombay or nearby or otherwise also, we keep hearing the news that probably every monsoon, there are few buildings that go out because they were supposed to be demolished, they were never demolished. And then of course, along with that goes lots of lives also. You have almost like 95 lakh bridges. And Mr. Bhaumik was there with me when we organized this particular event, when we were looking for, the health assessment of the bridges in the country. And so many bridges are there. And at least 9 to 10% of these bridges need total demolition because they have outlived their lives. The ground situations have changed. And of course, one of the reasons, especially for the buildings and bridges, is that they have outlived the utility. Think about it, expand it to many of the chemical plants, many of the energy plants, many of the other utilities that we are making. The situation is that demolition is something which has to be done now for quite a substantial lot of the assets that we have today. And then there is a problem, connected problem, which is a very important problem, that we do not have adequate number of people, organizations, and of course, the research personnel who could possibly take up this kind of work. That is something which is basically causing a lot of concern as a national policy formulator in my mind. So we had been talking to Ministry of HRD, All India Council for Technical Education, to explore the areas where the young engineers can be inducted. So we have the health assessment of bridges, we have health assessment of buildings, we have health assessment. Beyond the health assessment, here is a situation where we require this particular faculty also to grow. You need a lot of demolition to be done, and demolition is a serious business. It cannot be played around like construction can be. You know, the mixed quality may be poor. When you're making a virgin construction, the structure is still would stand. You can do some blunders in constructing the things, the structure is still will stand. But demolition is something which is almost like flying the aircraft, where the factor of safety is almost one. You do not even have the choice of basically committing one little bit of mistake also. So you require a specialized people, you require a specialized agencies. And on the contrary, what is happening here is that if we look at the lot of young engineers who are coming, and this is a part of the national planning, this is what I'm sharing with all of you. Almost 38 lakh seats for young engineers are available in the country today. Divide that by 4, that's the number of engineers who are coming out of the colleges. That is another story, that out of 38 lakhs, there are hardly about 24 or 25 lakh students who are actually now choosing to go for engineering, unlike what used to happen in our days when the numbers were far too smaller. Now, where exactly these boys and girls are going to go and work if we do not give them the new avenues to work on? So this is my quest, to look at this particular area, which requires a substantial number of manpower, which can be made a specialist lot. And not only that, they would be serving our country, but also this is a wonderful material available for export. They can go to any of the countries, they can work there, and such services are needed everywhere. You look at the city centers, don't go very far. Right within the SAARC region itself, city like Kathmandu, cities like Dhaka, or even number of them in Pakistan for that matter, including Karachi and all, they are bursting at seams. New spaces will have to be created. Buildings have outlived their utility for that matter. Where are the people who are going to be demolishing it in a systematic manner so that more land is available? Like they say, the land is not being manufactured anymore. We have to basically do with the thing. Look at our own cities. Look at Bombay. Look at Delhi and Calcutta. Bangalore also has started growing into that direction. Almost 60% of the land area is actually acquired by the slums, which has to be cleared so that a systematic new townships can come about. Delhi, almost 60 to 70% of the land area. Fortunately, we have plenty of land in Delhi, almost give or take 2,000 square kilometers. But then, as I told you, land is not being manufactured anymore. And much of the land has already been acquired. I came to city of Delhi in 1980, and that was a time when we still could see right in the middle of the city many open areas. No more, you don't find them there. And there are semi-pakka structures that have been constructed there. There are illegal constructions that have taken place. They are endangering the lives of the people. And God forbid, tomorrow, if there is a kind of incidence of earthquake, we are still in the zone 5 or something. And if the collapse start taking place, boy, I think we are going to have a tough time. So therefore, municipal corporations, civic authorities, they will have to be woken up to make sure. And of course, the transportation authorities, we are already talking to them, that now this is the time that this one particular area definitely needs an attention. But then the counter question that comes my way when I speak to them about it, they say, where are the agencies? Where are the people? How many people in India can do this particular kind of a thing? Are they really qualified? Do they really know their job and things like that? So when I looked at this particular aspect being deliberated, I thought I must come in here and speak to you from a different perspective altogether. Your presentations had been excellent, and I was almost like loving each one of them. You have done a wonderful work. We now need to coalesce our resources. We have to see and take up a three-pronged strategy. Number one, develop more and more people who can acquire this knowledge, and those who can basically go and start extending the services. And as I told you, it is thorough professionals who will be needed. So I would expect that some of the industry leaders who are right here, who have been speaking, they must come forward. We can set up some kind of a working group where we start looking into these aspects, where the personnel, where the individual organizations, they now need to be created. If we do not do that, then in that case, I think when the need arises, then we are just care of God. So I thought that I'll move the discussion purely from the practical point of view as to what are the kind of things that need to go in the national policy. And that's where I thought I should be speaking to you. So with that, I will basically open the deliberations of all the esteemed speakers who are here. And thank you so much once again, Mr. Bhaumik, Mr. Rao, Mr. Manoj, having invited me here. I really loved every moment of it. Thank you so much and God bless you all. And I think let's have an agenda for action so that we can start moving in this direction. Thank you so much.
Thank you, Dr. Swarup. That is a very revealing and a very important statement that you have made, and a completely different perspective on this whole subject. And you have raised some very, very important and very pertinent points, which only you could raise, being in the national policy level making level. And I think I fully agree with all that you have said. And you have pointed out that we have got a large number of legacy buildings which are very old and which are aging and which may collapse at any time. And there's a lot of substandard construction that is going on in the country. And you also brought out the importance of structural health monitoring, which is very, very important. And the biggest thing that you have raised is actually the need for specialist engineers who need to be trained in this entire subject. And I would also add to that we need to also train people in doing forensic analysis, because that also forms a very major part of any demolition program. Quite apart from the fact that you need to assess the conditions of buildings. So, in fact, in this respect, I started the first International Forensic Conference in 2013, and then subsequently in 2016 we had a second international conference. And what I'm happy about is that after the 2013 conference, a large number of institutions and universities have started courses in either full MTech courses or PG diploma courses, or even elective subjects in the master's courses in forensic civil engineering, which is a very, very heartening thing. I now request, I will open this to Mr. Anil Joseph, if he has anything to say on the matter.
Yeah, good evening once again. So indeed, like Dr. Swarup sir pointed out, we need a lot of engineering to happen. And I would like to share a small incident when we were selecting the bidders for the blast in this Marad. And in fact, we didn't have anyone from India which was coming in, even though Edifice did. It was the entire pre-qualification was only for jet demolition from South Africa. And they were winning the award 3 times for the best demolition company in the world. So we were very confident about them, and as the person who was deciding on, I wanted all the 5 towers to be demolished by jet demolition. But in fact, we had a young dynamic civil engineer who was an IS officer who was in charge of doing this. He told, no, let us train some Indian people. Anyway, we will be learning the technology. So let us learn the technology from these South Africans and pass on to our team also, so that at least 2 buildings let the be given to Vijaya Steels from Chennai. For him, Anand Sharma was doing the job, but he has not done anything of this scale. Maybe even 10% scale is what he has done before. And we had Sarvate who had done a lot of demolition, who got the Guinness Book of Record for the maximum demolition. But then those were all dilapidated structures in Bhuj, after the Bhuj earthquake, and very minor structures in complicated environment. So end of the day, we were able to bring in a team from India, and finally Anand Sharma successfully did the demolition, because whatever we were learning, and like Indians, we learn very fast. So given the opportunity, for me in October 2nd, I didn't know what was demolition all about. And when I was interviewing Joe Brinkman, I have done so much of homework that I know what was it about on the paper. But by the time when it was about to blast, we were confident that this is going to work. So that is the pickup level of our engineers. Definitely, like Swarup sir told, we have to start planning for this. There are so many buildings which is threatening to the society, and we have to come up with systems for, like there were excellent talk on jaw crushers and other aspects also. So it is not only the implosion by explosion, but let us work out the systematic way for decommissioning of the projects. And being a person coming from the state of Kerala, we are sitting under Mullaperiyar Dam, which was constructed so many years back, and the safety is always under question. If the dam bursts, there are about 10 lakh people living underneath, including me. So there is always this question: how long is the life of the building, life of the dam, which was constructed about 160 years ago? So these sort of questions, as engineers, we need to think and plan and come up with a solution to the problem.
Thank you,
very
Dr.
much for the
Joseph. Thank you.
opportunity.
I would like to pose a question to Mr. Jain. How long did it take for you to do the preliminary engineering for the demolition process before you actually started undertaking it? I mean, I'm just talking about the planning of the entire sequence of demolition and so on.
Actually, the entire process took almost 1.5 years. But out of 1.5 years, more than a year was taken as a basically administrative time. And once it was decided to go for this demolition, we prepared the scheme, and there was a series of discussion took place between railway engineers and us, because ultimately it is the safety of the railway which was the prime concern. So in that process, there was some 3-4 meetings that took more than 3-4 months. But after, once it is decided that this will be the final scheme and you have to go this way, it doesn't took much time. Only 1 month by us for preparation of the scheme, and then approval from various agencies like Proof Consultant, ITBHU, then CRS sanction, then railway approval. That will take that took only 2 months or so.
So most
So
of it was really administrative, you would say.
1 year was for administrative month.
Okay, the technical part of it itself was just about 2 months, is it?
Yeah, not more than 3 months.
Not more than 3 months. Thank you very much. Mr. Rajboj, you spoke very lucidly on the demolition of the Mahatma Gandhi Setu. In your case, how long did it take to plan the entire demolition, and how long did the actual demolition process take?
See, the demolition assessment or the design calculations took almost 3 months, because we were assessing where the cables are, whether they were routed and all those things. And then the calculations and the eccentricities of the cables and the approval processes, it took around 3 months for us to completely assess the demolitions and the design calculations for demolitions of the superstructure. But while doing the demolition, there was different time scale for water-based spans and the land-based spans. The land-based spans, using jaw crushers, we were about to do 5 spans in a month. But for water-based spans, which were being done by the cantilever construction gantry and the diamond rope cutting, we were able to do only 1 span a month. So we were having a 4 set of cantilever construction gantries, so running parallelly. So we were doing 4 spans in a month with 4 sets of the gantries.
In fact, thank you, Mr. Rajboj. In fact, there's a question that was asked in the question and answer box, which also has been working in my mind for a very long time. And that is, much like we have a built-in obsolescence in equipment, electronic equipment or mechanical equipment, where after a certain time they become useless or unusable, is it also not very, very important for us to, in our design system, to be able to actually plan for the building to be demolished at the end of its life? In other words, design the structure so that it can be demolished easily. What would you say that, Mr. Rajboj, first starting with you?
I mean,
that is built-in deconstruction. Let me put it that way.
Built-in. Sorry, sir. If you can repeat, I mean, I do not get the gist of your question.
No, what I'm saying is that in much the same way that equipment are designed to fail after a certain time to make it unusable. In the same way, when we design a building and when it comes to the end of its service life and it needs to be demolished, don't you think it would be a good idea to actually design the building such that it can be demolished easily or in a safe manner?
See, that is the thing which we don't plan actually for a demolition before we actually design and construct, because we design the building for a span of according to the code requirement and the durability limits we span, or we design the building or a bridge for 100 years of life. So we don't plan it that way. So for a demolition purpose, but it's a very good idea that we should be following up, because someday the building or a bridge needs to be dismantled.
I think from all the three of you have spoken, what has become very clear is that you need to do a tremendous amount of analysis of the structure itself to find out what is the best way of demolishing it. So if our training is such that in addition to designing building to stand, we must also incorporate some kind of system where you design a building so that it can be easily demolished, and you have what you call a detailed guide about how to go about demolishing a building once it comes to its service life. Of course, service lives today are going up to 7,500 years, but nevertheless, if there is a way of documenting all this, I think it will be very, very useful for its ultimate removal or deconstruction. Anyway, we are running out of time. I think we are 3 minutes or 4 minutes over time, but that's, I think, quite manageable. Thank you all very much for your very interesting presentations and a very lively panel discussion. Now we have got time for just about 10 minutes or so for any questions and answers, but I think most of the questions and answers have already been, course of questions have already been answered in the question and answer box. But if there is anybody in the participants who would like to pose a new question or which has not been answered, or whatever, you can please unmute yourself and ask a question. We have just got about 10 minutes. Please go ahead.
I think there are 2 or 3 questions which are there in the Q&A box still remained unanswered.
Okay, I'll just read that. One is from Nandulal Dasgupta. How to assess the cost of demolition and how to assess fees for demolition schemes? Anybody can answer that? How to assess cost of demolition and how to assess fees for demolition schemes?
No, to answer that question, it depends upon the type of the structure and the magnitude of the, the quantity of the work involved in that. So it's very difficult to say at the moment what is the fees for the demolition and design fees. It depends upon the consultant. Maybe Mr. Alok Bhomik may be able to answer the question about the design fees, isn't it?
No, I think Shashank, you absolutely made it right that it depends upon the type of structure. It depends upon your kind of experience. I mean, first of all, if you do not have any experience and exposure, you should not bid for or you should not quote for the job. You should only bid for the job or give a fees only when you know the subject. And if you know the subject, you will have to study very carefully the drawings and the situation, assess the type of demolition which you are planning, and accordingly you have to put your fees. I mean, it is something which is quite complex.
Maybe Dr. Joseph can give a more clear answer, because he was asked to demolish the building.
Yeah.
And because he designed the building and then he was brought in to demolish the building. So was the fees forced on you or did you have quota fees?
No, actually, for the engineering part, we didn't took any fees on the consultancy. It was a service given to the government because we were worried from the society point of view. So many buildings are under threat when these buildings are coming down. But regarding the fees of this thing, it's quite interesting to note that we had 16 players and who came in, and we played with only about 2.5 crores of rupees to demolish 8 lakh square feet. Because the reason was that Jet Demolition want to come to India and they have charged only 10% of their value overseas. Then they want to demonstrate that in India. So that was one reason why it has come down. Second aspect is that during this demolition, what we learned is that we were worried about the debris. We were worried how we will manage this huge debris, what to do that. We went for a tender and we got 45 lakh rupees for that. And they have retrieved 8,000 tons of steel, which went for recycling. That Vijay Steels has got the steel. So there is a lot of money they had made because these buildings were very healthy buildings, which was dismantled due to CRSF problem. So in fact, the demolition agencies have made a lot of money out of this process. And from the engineer's point of view, it was a service to the society because the motive was that I was the person who constructed the building. And anyway, it has to be sacrificed. it has to be sacrificed, then I want to make sure that the neighborhood or the entire society was glued to the television for almost 2 months, seeing the day-to-day action, and we wanted to bring it down in such a way that there is no other damages. As a
So you
person
also
who
got
created that,
so
we
you also
wanted
got
to
a lot
ensure
of
that it is done.
publicity. So you
Yeah.
also got a lot of publicity.
It's a publicity is actually what happened. The one thing which I told Joe Brickman on day one was that, Joe, you might have won the award for the best demolition company for the last 3 years successfully, but here you have a challenge. You have to convince the person you are going to demolish it without making any harm to the neighborhoods, because I am the one who has designed this building, and as the father of the building, I am the last one who has to go to sign the document which is allowing you to go ahead with the demolition. So technically, I have made the condition that I have to finally sign on the paper, and for all reason, I believe that it is not going to happen. I believe that Supreme Court will come up with a stay order, and even when we are drilling the columns, I was drilling it in such a way that I can rejacket it. So there was a hope against hope that one day we will be able to retrieve that. But unfortunately, the court was very clear. The law is above everything.
Thank you, Joseph. Dr. Swaroop, you wanted to say something?
Yeah, I really wanted to say something. These questions are very pertinent and relevant, and especially from the perspective of the owner, who is actually a government organization, because they have this system of looking at the schedule of rates and kind of estimate of the activities that are done. And I keep facing this problem from one more count, and that is actually how to handle the trenchless technology business in the country, because each problem is very unique, and you cannot basically have one kind of situation where you can come out with some prices. So I think one thumb rule which I keep giving to all the project authorities when they come out with such kind of requirement is that this is a project which can be done only on the cost plus basis. There is no other method of determining as to how much money would be required. Now, as far as the salvage resources are concerned, like I was listening to the other esteemed speaker when he said that so much of the steel was retrieved and 8,000 tons of steel was retrieved and sold. That is actually the bonus that should not be taken into account. Like in Delhi, it's a very, very common practice that if you have to dig the basements of the buildings that you make, as a matter of fact, you don't spend any money. You ask the contractor who will come and dig the basement for you and pay you the money, because that earth is needed elsewhere for backfilling and things like that. So I don't think there is a very straightforward kind of solution. And such solutions are very unique in the nature. What is the method of demolition? What is the proportion of usage of explosive versus the kind of mechanical or application of forces for that matter? These are the kind of things that have to be determined and designed by the person who is doing it. But one thing which I can tell you for sure, that all the methods and all the systems, they have to be taught to the people who really undertake this kind of assignments. If they do not know what they are doing, and God forbid, if they get into this business just for the sake of doing the business, I think they are getting into a very, very difficult terrain. Very difficult terrain. It's a very morbid business also. But then morbid things are needed in the life of humans also. After all, when you set up the towns and cities, setting up crematoriums and setting up burial grounds, that is something which is an integral part of the cities. So while we are constructing with full gusto and everybody is looking at development in terms of constructing the things, I think this is one area which definitely does need a lot of attention and creation of people and organization who can very wisely execute such assignments. Thank you. That is what I had to tell.
Thank you very much, Dr. Swaroop. And I think that brings us to the end of the question and answer session. I am very grateful to all of you for having maintained the time so meticulously. And this is one of the very few webinars where we are exactly on time. We are supposed to finish the question and answer session by 6:10. We are at 6:12. So we are not too bad. So thank you very much indeed. It has been a very informative and a very educative webinar. And I must thank all of you once again for all your wonderful inputs. Thank you so much. I now hand it over back to Mr. Alok Bhaumik to take it forward. Thank you.
Thank you. Thank you, Mr. Rao for such an excellent moderation and sticking to the time for every speaker. And end of the day, we have finished it in just in time. I just would like to stress upon 2-3 points before I hand over to the president to conclude. Number one, we in India, our makers have not really, thought about the dismantlement as an easy as a subject, and we do not have presently any codes, neither BIS code or IRC code on dismantlement. I can tell you that there is a model code FIB model code 2010, which talks about, there is a full chapter on dismantlement, how to do the dismantlement. In fact, dismantlement is an integral part of the design itself. Any building that you design, uh, the code provides for, there has to be a method for dismantlement. You have to design from cradle to grave. That's the concept. So dismantlement has to be a part of the design itself, number one. Second, the methodology to deal with the material, the disposal of that material, that has to be a part of the design in the initial design itself.
You've suddenly gone off air.
Audible now?
Not fully, not yet.
Allow there's some problem on your side.
Is that a bandwidth problem?
Hello?
Yeah, your screen is frozen, Mr. Bhomik.
Might be some connectivity issue.
I think it's a connectivity issue, yes.
Should I conclude now?
Yes, sir. I think you have conclude, please.
Okay. We are getting late, so I think I don't have much to say. Only thing, I just want to thank everyone, all the speakers who really made very impressive presentation, and it was a very new field. So I think everybody must have learned a lot from you. Thank you, everyone. I just want to request all the speakers.
Hello?
Alok has come actually. Okay. Okay, Alok.
Yeah, I just wanted to, give me just half a second.
Yeah.
Just 10 seconds. I just wanted to mention that the dismantling and the disposal of the waste is supposed to be an integral part of the initial planning itself. And after this webinar, I would like to propose to our president that ISRT may come out with a guideline for dismantling of the structures on the basis of what we have heard today for buildings and bridges. We can come out with a small guideline on dismantlement of structures.
Yeah. So I was just saying that I will request all the speakers to, if you can contribute a technical paper on your work which you have done for publication in our technical journal. I think Mr. Sanjay Jain, which made the presentation, I think that has already been published in one of the SED. But other two public thing we can publish in our SED. I think that can be a very good paper. That will be a very good paper. You include all the technical aspects of that, how you did the demolition, what kind of technique you used, what kind of material was used, and how you analyzed it, and all those things, whatever you can do. So I think it will be a good thing. Now, second, the Alok was saying we should come out with a guideline. Yes, we can request our publication committee to look into it, and we can take your help in developing that kind of a guideline. It is a very, really, it will be a good thing. Another information I wanted to give to everyone, to all the participants also, on the 30th of August, we are organizing another webinar on a very interesting subject on fire, structural fire safety. So that is now we have done a MOU with the School of Planning Architecture and Institution of Fire Engineers. So we all three are jointly organizing this webinar, and this will be a series of webinars on structural fire safety. And we are also planning to publish some kind of a guideline for structural fire safety. Similarly, we can do for demolition also. So that thing we will do. So I will request everyone to join on 13th August at 3:30 p.m. That time is a little early because the main speaker is from UK. So we have done timing accordingly.
Manoj, just
Yeah.
one thing.
Yes.
Many of the participants are asking for the handouts of the presentation. They're asking whether that would be made available. So we can request the speakers to give the handouts of the presentation for circulation to all the participants.
Yeah,
Yeah,
of course.
if you
Of
can
course.
share your presentation, then it will be very nice. We will share with our participants.
So where should we send it? Which link and this paper?
To IS Takti. We will send you the email ID. We will give you the email ID. We will send you a mail. We'll give you the
Okay.
Okay, even the paper, if you have requested for the technical paper, so kindly give us where we need
We
to
will
send
give
it.
you all the details. You kindly contribute your technical paper. It will be very nice. Thank you.
Okay, thank you very much.
Visalakshi, you want to do something? We have our honorary secretary Visalakshi here. She wants something.
Hello, everyone. It was a wonderful.
Conclude the matter. Conclude the webinar.
Okay, thank you, Mr. President. Thank you all the speakers. It was a wonderful webinar, and see, we structural engineers are accustomed to hear about the construction techniques, design techniques, so on and so forth. But this could be the first webinar on the demolition, and I think many of our participants have at least got an awareness that this is a subject to be aware of. Okay, all engineers, not only the construction techniques and the design techniques, they need to be aware of the demolition. Okay, I thank each and every speaker for making us aware of these demolition techniques. Thank you so much. And Professor Swaroop, thank you so much for being a panelist. And we are glad to have you on this platform, sharing your knowledge. And as you said that it is very important to create a skilled person and a trained person in this area. And maybe AICT or the UGC can come up with some guidelines for the civil engineers to have a capacity building in these areas. As we all know that in the engineering colleges, there is a lot of the colleges are facing lower admissions in the civil engineering department because they are not able to get the jobs. So this might be an opportunity for us to approach AICT and UGC to create awareness and capacity building in this arena. Thank you so much, Professor Swaroop. And Mr. BSC Rao, thank you for being the moderator. I think you have perfectly moderated the session as per the timeline. Thank you so much. And last but not the least, Mr. Alok Bhaumik, thank you for connecting the events. Okay, we have lot many events and webinars coming up for the structural engineers. Thank you. And at last, thank you, participants. And please do participate in the upcoming webinars and the refresher courses. And do give us the feedback so that we can improve upon these webinars and the courses which we are conducting on the IS Turkey platform. Thank you. Thank you so much. See you in the next webinar.
Thank you.
Thank you all.
Thank you.
Good night.
Thank you, Dr.
Thank you.
Visalakshi. Thank you, all the participants.